I'm going to talk a little bit about the bones, joints and movements of the hand. But what I'd like you to do also is, while I'm going through this, if you can, anytime I talk about a bone, if you can locate it on the skeleton that you have there, but also locate it on yourself, so you'll be doing some surface boundary palpation as well. There are a total of 27 bones in the hand, 8 carpals, which are all short bones, so please locate those on your skeleton there. The proximal row of carpals are the scaphoid, lunate, triquetrium and pisiform. We're going to learn these, and we're going to find an easy way of learning them so you all know them by the end of the session. The distal rows are trapezium, trapezoid, capitate and hamate. There are 5 metacarpals, which are all long bones, so that's these ones. You can locate them on yourself or on your skeleton there. There are a total of 14 phalanges. The singular is phalanx. So there are 14 of those long bones. In the thumb there are only 2 phalanges. Here and here. In each of the fingers there are in fact 3 phalanges, which is the index to the little finger. So a total of 27 bones in each hand. Here they are again. So those 8 carpal bones. And that's the scaphoid, lunate, triquetrium and pisiform, which is a proximal row. The distal row is trapezium, trapezoid, hamate, capitate and hamate. And these are the metacarpals, numbered from the thumb being number 1. So 1, 2, 3, 4, 5. And then those are the phalanges. Moving on, looking at the joints of the hand and their movements. The first one, the joints, is the commonly called the wrist joint. It's the radiocarpal joint. And this is where the distal end of the radius articulates with 2 of the carpal bones, which are called the scaphoid and the lunate. And they form what is called an ellipsoid or a condyloid joint, which is similar to a ball and socket joint, except that you have an oval-shaped ball and an oval-shaped socket. The movements that are permitted at that joint: flexion, extension, if you can do that movement now. So from the anatomical position, flexion is this, extension is that. Abduction and adduction. So abduction is away from the centre line, and adduction is towards the centre line. Did you know that there is an alternative name for abduction and adduction? So abduction is also called radial deviation, so moving the wrist towards or the hand towards the radius, and adduction is ulnar deviation. Circumduction, do you want to know what circumduction is? So we want to do circumduction together. It's where the distal end describes a circle. And because of the oval-shaped surfaces, there is no such thing as axial rotation at the wrist joint. It can't rotate on its own axis because, unlike a ball and socket joint, which can rotate on its own axis, because you've got an oval-shaped joint, it won't rotate. To make up for that, we supinate and pronate the hand. Carpal joints. So between each of the carpals, there are joints which are, by definition, synovial plane joints, and they have no axis of movement, so they're called non-axial. And the movement that occurs within them is a minimal amount of gliding, and they're also supported by very strong ligaments that reduces that gliding even further. Then we have the carpal, metacarpal joints. This is where there's going to be a bit of controversy, believe it or not. This is where the distal row of the carpals articulates with the base of the metacarpals. This is the distal row of the carpals here, with the base of the metacarpals. 2 different references describe them as being 2 different kinds of joints, so you can make up your own minds. In digits 2 to 5, which is the index through the little finger, some authors define them as being ellipsoid joints or condyloid joints, which means they have the same axis of movement as the wrist joint. So flexion, extension, abduction, adduction, and circumduction. However, most textbooks define them as being planar joints that allow a minimum of gliding movements. If you look at these joints here, which are the joints we're talking about, and you look at the structure of them, compared to these ones which are true ellipsoid joints, you can probably make up your own minds. So what do you think?
Planar joints.
Yeah, they look a lot more like planar joints. But 2 different opinions there. Then there are intermetacarpal joints. between here and here, which are also planar or gliding joints that provide minimal movement. The most mobile of those is definitely the fifth digit. So if you just hold your own fifth metacarpal, you can move it in flexion extension. You can also move it into abduction and adduction, and you can also circumduct it.
Get around it.
At least passively. Oh yes. So it's kind of leaning towards this hypothesis a bit.
Tight.
Moving on, the carpal, metacarpal joint of the thumb. This is a unique joint that we've all learned about, which is a saddle joint. This is where the trapezium, which is one of the carpals, articulates from the base of the first metatarsal at what we call a saddle joint, which literally looks like a saddle, which is that one, and a rider sitting on the saddle, like that. It has 3 axes of movement. You might have learned something different here. 3 axes of movement. Flexion, extension occur. I'll define those movements. If you put your hand up like that, flexion of that joint will be moving across the palm. Extension is moving back the other way. Abduction is moving upwards, and adduction is moving back. So that's the definition of those movements of that joint. Opposition is the movement of bringing the thumb to the opposite fingers, and it's during that movement that there is 17 degrees of axial rotation of the joint. So that gives you your 3rd degree on movement.
Monkeys.
And that's what makes humans unique, is that the ability to oppose the thumb. The metacarpophalangeal joints, this is basically, where are they? Our knuckles. So between the metacarpals and the phalanges, this is where the heads of the metacarpals articulate at the base of the phalanges. So there's the metacarpals at the base of the phalanges. They are again condyloid joints. The picture here is obviously the wrist joint, but it's showing a generic condyloid joint, which has only 2 degrees of movement. Flexion, extension, that movement. Abduction and adduction. And normally abduction and adduction are defined from the midline of the body, but in the hand, the midline is actually taken from the middle finger. So abduction is moving the fingers away from the middle finger, and adduction is moving the fingers towards the middle finger. Circumduction. Finally, the interphalangeal joints. This is where the head of the more proximal phalanx, note the word phalanx is a singular of phalange, so the head of the more proximal phalanx articulates with the base of the more distal, and it is a hinge joint. That picture there is obviously the elbow joint, and is an example of a hinge joint. Movements are basically flexion and extension, so it's a uniaxial joint. So let's learn the carpals using this mnemonic. So everybody say after me. Slowly. Lower. Tilly's panties to the curly hairs. Tilly will be very grateful. Can you all please get a piece of paper and a pen? And I would like you to draw this picture. Starting off with the radius. Next to it, ulna. And then the proximal row, we're only going to draw 3 carpals, so slowly lower Tilly's, and then the pisiform sits on top, like that. This is an anterior view. Alright, so proximal row, slowly lower Tilly's panties. And then the distal row has 4 to the curly hairs.
Right line.
So what are those carpal bones? Scaphoid.
Talon's pairs.
Lunate. Yeah, you could substitute a male name there. Triquetrium, pisiform, trapezium, trapezoid, capitate, and hamate. So let's palpate and locate these carpal bones. Put out your hand. If you trace from the little finger through to the wrist crease on the little finger side and palpate there, you'll feel the bone. That is the pisiform.
Yeah.
If you then move distally and in the general direction of the ring finger, about a thumb's width, you should be able to feel the hook of the hamate. Yeah? If you then go back to the wrist crease and move towards the thumb side, you should be able to feel the tubercle of the scaphoid. And then if you move directly distally from there, you should just be able to palpate the tubercle of the trapezium. You've just located, in fact, those 4 tubercles are where the carpal tunnel, the transverse carpal ligament attaches across those to form the carpal tunnel. That is the topic of another lecture. Thank you very much.
Yeah!